G'day chemists. So today we are going to have a look at an IB question from paper 1A. That means it's a multiple choice question, and we're going to be looking at oxidation numbers. It's something that students find really straightforward when they're studying it, when they're learning it. During the course it's not particularly tricky. Oxidation and reduction can be. Maybe we'll have a half equation question coming up because that's something worth revisiting. But it's something that people tend to find pretty straightforward during the process of the study. But when it comes time to the exam, they're questions that aren't always done super well. And one of the reasons is I think that it's like you do it, you're learning it for about half an hour. And then, unless you're really conscious of making sure you go back and do them every couple of weeks, you kind of forget how to do them. And in the heat of the exam, it can get confusing. And this question's, it's a bit of a tricky one with that respect. So let's have a look at it. Alrighty. So, in which reaction does H2 act as an oxidizing agent? N2 plus 3H2 goes to two ammonias. Sodium plus hydrogen gas goes to sodium hydroxide. Sodium hydride. Chlorine gas plus hydrogen gas goes to hydrochloric acid, or hydrogen chloride, I suppose, as a gas. What's that going to be? That's going to be ethene. Ethene plus hydrogen gas goes to ethane. Alrighty. So pause the video there and do the question, and we'll come back in a sec. Alrighty. So let's have a look at this fun question. I like this question, but as I said, it gets tricky if you haven't practiced them for a while. So we're looking at hydrogen gas in this one, acting as an oxidizing agent. So that's a species that oxidizes another one. Therefore, we're looking for hydrogen being reduced. Now, what strategy are we going to use? We're going to look at the oxidation numbers. Remember, oxidation is loss of electrons, right? Reduction is gain of electrons. That's that oil rig. Oxidation is loss, reduction is gain. So therefore, if something is being oxidized, its oxidation number increases, goes up. If reduction is happening, its number goes down. Oxidation and reduction, you need to practice it because it gets confusing. Yeah? Okay, so therefore, we're looking for the one where the hydrogen's oxidation number or oxidation state goes down. Alrighty. So it's important to remember that hydrogen usually goes to +1, right? In most of our reactions, this is what makes this an interesting question, is that hydrogen usually goes to +1 as it loses an electron. So that means, like, when we go from hydrogen gas to whatever the hydrogen is in, it's typically oxidizing and is therefore a reducing agent. So we're looking obviously for the one that's an oxidizing agent, but just know that that's a bit weird, right? Like, that's out of the ordinary. Sorry, I'll stop waffling. Alrighty, so first one, oxidation number for nitrogen. So gases, not gases, elements on their own in their normal state, it's usually 0. So nitrogen 0, hydrogen 0. In this case, the nitrogen is a -3. Okay, and the hydrogen is a +1 because the hydrogen has oxidized and given numbers to given electrons to the nitrogen. Alright, because valency of nitrogen is always like that -3 and so on. Next we skipped one. What does that mean? Chlorine gas plus hydrogen gas goes to hydrogen chloride or hydrochloric acid. So the hydrogen in this case is going to be a +1. The chlorine or chlorine is a -1 nearly always. Down here we're at the ethane. So the carbon here is at an oxidation state of -2. Both of them are at -2s. This is a +1 over here, but you've got two of them. Same deal over here. And this one's going to be at 0. Over here, it stays at +1. And these goes to -3. So once again, it's, what are we talking about? It's oxidized, because it's gone up. And that leaves us with B, alright? So we have a 0 and a 0. Here, the sodium loses electrons. We get an ionic bond here. So there's going to be a +1, -1. Holy dooly. The hydrogen has been reduced, which means B is our answer. Alright, so that was straightforward, but again, it's tricky in that it's something the students don't often practice. So make sure you are. I'd be very shocked if you don't run into a question like this doing with oxidation states in the exam. Okay, so what are our takeaways with this question? You just need to understand and memorize the rules of oxidation states. You got to practice them. Practice oxidation. Know the language. Know the tricky ups and downs with numbers and such. Yeah. Any questions? Pop them in the comments. If we've made a mistake, let us know, by all means. And give it a like if this is helpful. That helps us out. Hit subscribe so you can keep up with all of our other questions, whether you're a student or a teacher. Maybe these will be useful for your class. And we'll see you tomorrow. Good luck. It's getting close. We'll see you then. Bye.